Before properly starting with the course, I wanted to give you some motivation. Why would a scientist or a mathematician need to learn how to program? Well, it's an important need nowadays, and there are many different reasons, but let's break it down according to your intent later after your studies. If you're a mathematician, there are three career options in front of you. You can start working in the industry, you can do mathematics research, or you can go into teaching. If you're a scientist, it's essentially the same. You could go into the industry, you could do research, or you could teach at high school level, for instance. In each of those, you will need computers. So let me explain to you why. So in every single industry you can think of, computers have changed things or are about to change them. The reason is always the same. The software helps to program new tasks and to reach new levels of automation, new levels of distribution, new levels in every aspect. Having the software, having the task program helps you do it more consistently, faster, cheaper, etc. So that's why programming, the fact that you know how to program, is a tremendous advantage for any job offer. Actually, it's even worse. Not knowing how to program could be a huge disadvantage for you later when you work in the real world. Now, if you're about to do research, if that's what you want to do later, even in math research, it's important to know how to program. You can perform experiments, what scientists in other sciences would call experiments. You can do simulations, you can test your ideas. And for this, there are many different programs you can use, different computer algebra systems you can use, such as Mathematica, MATLAB, or Sage. Finally, if you teach, well, you're likely to teach the next generation, the next students that will come. And it will be even more important to be able to teach them programming, because this will be a required skill in modern society. Some people compare programming to literacy. So the fact that you know how to program will be just as important as the fact that you know how to write in the future. So maybe that's a bit strong, but I think there is some truth to it. So programming is important, but you should never misunderstand what I'm saying. I'm not saying that the computer is ever a substitute for thinking. That's not true. But it will help you leverage the special knowledge that you have. For instance, if you're a mathematician, the fact that you know this deep mathematics will help you design new things or have new ideas, and it will be extremely important that you know how to program to actually be able to go to the next step. So I'll make sure with the homework, I'll give you very directed homeworks that will guarantee that you will learn the most important parts of the material. But in the projects, I want to really encourage you to explore the freedom you have. You should really try to suggest topics that are unexpected, interesting, different, and try to pursue them very, very deeply with the programming knowledge you've gained. That's a huge advantage of Python. The huge advantage is that you can use this language to do many different things. It's very general purpose. It's very well suited to do mathematics, to do biology, to do many different things. But it's also very well suited to do internet things, interact with computers over the internet, interact with web pages, interact with databases, and things like that. So Python is very special because it gives you skills that can easily translate in many different settings. It's a perfect language for a first-year student. So now the general goals of the course, or the general trends in the course. I'll try to communicate to you on three levels. The first one is I'll try to communicate basic programming concepts that are relevant for any language that you might be studying, Python, Java, etc. Then I'll communicate at the level of Python itself. So if you want to learn Python, you need to know some things about the syntax, and maybe even more important for Python, you need to know some things about good practices when you program in Python. So things that are recognized as good ways of programming, if you want. And finally, if you're programming, if you know how to write a program, there's a last step that is very important and it's often missed by the students or even the instructors, is that you need to be able to program for your science or your mathematics. You need to be able to translate the problems you are looking at into programs and vice versa. So this aspect is much harder to teach and much harder to test, and that's why it will be very well correlated with the projects. So in the projects you will have to do in the later weeks, very soon still, starting at the 4th or 5th weeks, you have to make sure to deepen your the mathematics or the biology or whatever that you are reaching in. So you have to really use the programming you're learning to relate it to more and more abstract problems.